Okay, I want to look at multiplying two numbers, first in Cartesian form and then in polar form, to show you how that works. Okay, these are the two numbers I've chosen. Z1 equal to 1 plus I, Z2 equal to 1 plus 2I. So to multiply them out, Z1 times Z2, I get 1 plus I times 1 plus 2I. That's equal to 1 times 1 is 1. I times 2I is negative 2. Then 1 plus 2I is 2I. And I times 1 times 2I is 2I. And I times 1 is I. So the number I get is negative 1 plus 3I. Okay. Now I want to take these two numbers and I want to put them into polar form and then do the multiplication that way. Now, if you remember, to put numbers in polar form, I draw them out on the axis here. Okay, so I have that this is the real axis, and this is the imaginary axis up here, and the real axis I'm out at x equal 1. The imaginary axis is y equal I, or 1 times I. So that gives me a point right up here. And when I put it in polar form, what I need to know is the length of this modulus vector, which I'll call R1. Okay, this is R1. And I need to know this angle, which I'll call theta 1. So this is my x1, and this is my y1 here. Now, see that y1 is equal to 1, okay, x1 is equal to 1, so theta here is such that they have the tangent of theta is y divided by x, or it's 1 divided by 1, 1 divided by 1, so tangent of theta is 1. So if I want to find the tangent of theta 1 here, I have to find the angle whose tangent is 1. I happen to know that because if this distance here is 1 and this distance is 1, I know that the angle is just pi over 4. So I can see right off the bat that theta 1 is equal to pi over 4. Now the length of this line we can compute from the Pythagorean theorem. Again, this distance is 1, this distance is 1. So I have the R1 is equal to the square root of 1 squared plus 1 squared, or just equal to the square root of 2. Similarly, I want to find what the number Z2 is in polar form. So let me write out that. Here's the axis here for Z2. Okay, so I have that for Z2, the real value here is 1. The imaginary value is 2. Here, let me make that 1 a little bit shorter. Let's say here's the real value of 1. This is 2, which is, let's say, up here. So that means that my point is out here somewhere. And the modulus, or R2, is this length. And this angle here is theta 2. So this is theta 2, where this is 1 and this is 2. This is R2. Well, similarly, we get that R2 is equal to the square root of 1 squared plus 2 squared. That's the square root of 5. And we need to find the angle theta 2, where the tangent of theta 2 is equal to the y distance, which is 2, divided by the x distance, which is 1. So the tangent of theta 2 is 2. Now we want to find the angle whose tangent is theta 2. There's a name for that function. It's called arctangent of 2, or as I prefer, the inverse tangent, and it's a function on your calculator. So we want to find inverse tan of 2. So you do that on your calculator, and I get that to be 1.107 radians. And you always do your angles in radians here. 1.107 radians. Let's see, back over here, pi over 2. So this is theta 2. Theta 2 is 1.107 radians, and R2 is 5, or square root of 5, sorry. And back over here, I have theta 1 is pi over 4. Let me compute what that is as a decimal. I have theta 1 is equal to pi over 4, which is, let's see, 0.785 radians. And I have that R1 is equal to square root of 2. Okay, so let's let me clear some space here so we can finish the calculation. Okay, so I want to now compute Z1 times Z2, Z1 times Z2, but things are now in polar form. So this is equal to R1 times e to the I theta 1, which is, I'll write it in brackets like this, 0.785 times R2, and I want e to the I, and here the angle is 1.107 radians. So here's the product. Now R1 is square root of 2 and R2 is a square root of 5. So this becomes square root of 2 times square root of 5 times the product of e to the I, 0.785, times e to the I, 1.107. Now when I multiply, I have e to a power times e to a power. Let me first multiply square root of 2 times square root of 5, which is square root of 10. Now this, when I multiply two numbers like this becomes e to the I times the sum of 0.785 plus 1.107. So the product of these two becomes e to the I of the sum. And this becomes square root of 10. And now I sum those two numbers, so I get e to the I, and the sum of the two numbers, hey, that doesn't look too good. Undo, so I get e to the I, and the sum of those two numbers is, let's see, 1.892. Okay, so this is the product of the two numbers in polar form. Now, remember that this is equal to square root of 10 times cosine of 1.892 plus I times square root of 10 sine of 1.892. Okay, so let me again look into my calculator. Square root of 10 times cosine of 1.892. See, in my calculator, that comes out to be negative 0.999 and plus I times square root of 10 sine of 1.892 on my calculator comes out to be 3.001. Okay, so once you have the numbers, the complex numbers in polar form, and you multiply them, the modulus of the product of the two numbers is the modulus the modulus of the two numbers multiplied together is the modulus of the product, and the sum of the angles is the angle of the product. And as we see, here's the answer that we get right here. Square root of 10 times that is the real part. I times square root of 10 times the sine of that's the imaginary part. And only because of decimal approximations on the numbers here, instead of -1, we get negative 0.999. And instead of 3, we get 3.001. Well, I'd say that that's good enough for government work. So that's how we do the product of the numbers when we have the numbers in polar form, and you can see that it gives the same answer. So we can do some examples of this later.